Hi friends, and now you are going to learn knapsack problems, right? So as earlier also we have discussed knapsack problems under exhaustive search, that is brute force technique. Then we have discussed the knapsack problems under branch and bound technique, dynamic programming we have knapsack, right? Greedy knapsack we have. So basically we are going to discuss in this particular topic knapsack algorithms based on approximations algorithms, right? Why it is called approximations algorithms? Again, this is the part of NP hard problems, right? So we are going to solve this knapsack problem more than one method. Maybe you're going to use the exhaustive search with the greedy method, maybe greedy method with the dynamic programming, and we will find a comparisons, right, between the optimal output, optimal cost, optimal profit, maximum profit. In case of knapsack, what is optimal solution is maximum profit, right? So earlier also we have discussed that knapsack problem basically is based on the given set of elements, weight will be given, all the elements corresponding profit will be given, and of course knapsack capacity will be given. Knapsack is nothing but container or bag, right? So each and every bag or container got their own capacity. So based on the given capacity, we are going to select the item such a way that sum of the weight of selected items must be lesser than the capacity, right? And keeping in mind, we are going to select the item not only based on the weight, but of course our overall profit should be maximum, right? There will be many solutions, but our focus is how we are going to select the items considering the weight and their profit such a way that overall profit of that knapsack problem should be maximum, right? That is why called optimal solutions. So here we are going to discuss greedy, knapsack and exhaustive search. We'll see that by both the way how you are going to find different solutions and what will be the approximations, errors, right? And of course about the time complexity. So it is a strategy for finding optimal solutions, maximum profit based on the selection of valuable items for the knapsack. So item weight and profit will be given. So V is a value of items where W is a weight of item. We are going to select such a way that profit will be maximum. So what happened in the greedy knapsack? Greedy knapsack is very simple. Name itself is greedy, right? So we'll have solutions will be having the decision based on the profitable items. And how we'll find out the profitable item or valuable item is if you're going to find the ratio of given items profit and weight should be maximum, right? So profit divided by weight should be maximum, hence you can say that that item is profitable, right? So first of all, you're going to find out, we are going to compute weight value to weight ratio, that is VI divided by W of I for all the given items. If number of items are n, so all the items are going to find V of I, W of I. V of I is nothing but we are talking about the profit divided by weight. We are going to find for all the given items. If this profit divided by weight is not given in decreasing order, right, then we have to make it, right? So step 2 is called sort this item in non-decreasing order means what? Non-increasing order means what? Decreasing order of the ratio computed in step 1. So we have to write first should be the profitable item, the next profitable item, the next profitable item, like this. So first profitable item should be at the first place, right? If there is a ties, okay, then you can break it in it arbitrarily. Repeat these following operations until no items is left, right, in the sorted list. If the current items on the list fit into the knapsack, right, place it in the knapsack and proceed to the next item. Otherwise, just proceed to the next item, right? What it means, we are going to select that item based on profit divided by weight. if that weight of that item is lesser than the capacity of the knapsack, then we'll select it. If weight of the item is more than the capacity of the knapsack, then you are not going to select it. But the greedy knapsack says that rather selecting that complete items, even you can go with the partial items. Even you can go with the fraction of items, fraction of their weight, in order to maximize the profit. So let us see that how you are going to discuss it. Here, if you are going to write profit divided by weight, right? Profit 40 divided by 4, 10, 46 divided by 7, 6, 25 divided by 5, 5, 12 divided by 3, 4. So this is already there in decreasing order, right? If after computing this value divided by weight, it's not in decreasing order, then of course we have to reorder it such a way that maximum profitable item at the first positions, then next, like it should be in decreasing order of their profit divided by weight. It should be very clear. And capacity of the knapsack is given, means bag container capacity is 10. Means you have to select the item such a way that we are not going to increase the sum of the weight of the selected items more than 10. If that is the case, we have to reject such items. Alright, so let us see different scenarios, right, and find the solutions. So let us see that. In this particular case, who is a maximum profitable item? Is first item having 4 weight and 40. So 4 is lesser than 10. Yes, 4 is lesser than 10. So hence we have selected this. And what is the profit? In that case, profit is P is equal to 40. So all 4 kg of that items, if you are talking about the unit, we have selected, and profit is going to be P is equal to 40. Next item, what is the weight of that item is 7, right? And what is the weight is left? Remaining weight is 10 minus 4 is 6. Now 6 kg is left in knapsack. Now let us see that next item weight is 7. If you see that 7 lesser than 6, no, it's not. It's not. So we cannot take 7. 7 plus 4. What is the 7 plus 4? Is 11 kg. And 11 is greater than 10. So it's not fitting into that knapsack. So hence we have to reject if you are doing dynamic programming of the knapsack. So dynamic programming will not allow you to select this item. Okay. So which one? As per the dynamic programmings, right, we have to select the whole elements. Hence, we are not going to select this item. 4 plus 7 is 11. Hence, we are going to reject, right? In that case, what will happen? We will go to the next item. What is next item? 5. And what is the? Is 5 is lesser than 6? Yes, right. So 4 plus 5 is 9. So we select this 5. 4 plus 5 is 9. Is 9 is lesser than? 9 is lesser than 10? Yes, condition is true. In that case, what is the profit? Profit is going to be previous profit 40 plus this 5 kg elements we have selected 25 plus 25 is going to be 65. Okay? 40, 25 is 65. You have selected. No. Next is 3 kg. Already, what is the capacity of the knapsack now? 9 kg is already done. If you are selecting this 4th item, so 9 plus 3 is 12. 12 is greater than 10. Hence, it is not fit. So, as per the dynamic programming, when you are selecting the whole items, what is the profit here? 65. Right? And what are the items you have selected for the knapsack? Item 1 and item 3 you have selected. Item 2 we have rejected because their weight of the item is 7. But remaining space left in your knapsack is 6. Hence, it has to be rejected. So, based on the dynamic programming, if we see that, right, our maximum profit, what is maximum profit here is? Maximum profit is 65. Right? An item is selected. What are the item is selected? Item 1 and 3 is selected. So, this is based on the dynamic programming. But what greedy knapsack says. Okay, what greedy knapsack says? Greedy knapsack is also allowed fractional weight. Greedy knapsack also allowed fractional weight. So once we are writing in a decreasing order, say item 1 is selected. What is the first item weight? Weight is 4. Is 4 is less than 10? Yes. So what is the profit? 40. Right? And what is the remaining weight? Remaining weight is 10 minus 4 is 6. Right? Okay. So this is a capital W is 6 now. Right? 6 kg still you can add. What is the next item? So this is the first item done. What is second item? Profit is 42. Weight is 7. Weight is 7. Is 7 is lesser than 6? No. So we are not in a position to select the 7 kg of that item. So greedy knapsack says that okay, you can go with fractional weight. How many kg you want out of 7? You select that. So how many kg you want out of 7? We have 6 divided by 7. This fractional weight I want. Out of 7 kg, we want 6 kg. In that case, what will the profit? Profit is going to be 40 plus 6 divided by 7 is fractional weight of the second item into, and what is the total profit here of the second item? 42. Right? So 7 6 42. Right? So what is the values? P is going to be 40 plus 6 6 36. So 76. Let us see that. Here we are getting the profit 76. What you got it over here? 65. Right? And if you are applying the greedy technique and fractional weight is allowed, then profit is going to be 76, because out of this 7 kg we have selected only 6 kg. So total profit is going to be 76. So there is a difference, right? We are getting the maximum profit in this case. Now let us see that. Third scenarios, when you are applying exhaustive search. Exhaustive search says that we have to work on the subset, number of subset, and we are going to iterate it one by one, item by item. Okay. So let us see that what are the items we are having in 1, 2, 3, 4, 4, 7, 5, 3. We have item 1, 2, 3, 4, weight and profit 4, 7, 5, 3, 5, 3. Here we have a profit is 4, profit is 42, profit is 25 and 12. Yeah. So exhaustive search says that we have to find out and work on all the possible subset. So we are going to find the subset, right? Since we have 4 elements, how many number of subsets will get? Will get many subsets. How many subsets will get? 2 to the power 4. 16 subsets will get it. Right? So total number of subsets, and we are going to find out total value or profit if it is fit. Okay? Selected item. Whether you are going to select item or not item, let us see that. Subset. If you are not going to select any item, what is the profit? Nothing. Profit will be remain 0. If you are going to select the only first item is fit. What is the weight? 4 kg. Right? So selected item is first. What is the weight? 4. And what is the profit? 40. So what is the profit here? 40 kg. Right? If you select only second item, then second item, what is the weight? 7, and profit is going to be 42. If you are going to select third item, right? What is the weight? 5, profit is 25. You are going to select fourth item, right? Then what is the weight? 3 and profit is going to be 12, right? Only for fourth item. Now single items you have already done. Now go with combination of first and second, first and third, right? First and third. Similarly, first and fourth. Then combination of second and third, second and fourth, third and fourth. So this is combination of two elements, and we will see that what is going to be outcomes. 1 and 2. Is it possible 1 and 2 items? What is first and second item? Weight is going to be 4 plus 7, 11. Not fit. Not fit, right? So will not have any profit. Similarly, 1 and 3, 1 and 3, 4 plus 7 is 9. So weight is going to be 4 plus 5 is 9. So it is fit, and what is total weight? Total profit is 40 plus 25 is 65, right? 1 and 4. 1 and 4. What is the weight? 4 plus 3? 7. And profit is going to be 40 plus 12, 52. 2 and 3. 2 and 3. Weight is going to be 7 plus 5 is equal to 12. Not fit. Right? Second and 4. 7 plus 3. 10. It is fit. 7 plus 3, 10. In that case, what is the profit? 42 plus 12 is 54. Right? Next, 3 and 4. 3 and 4. Weight is going to be 5 plus 3, 8. And profit is going to be 25 plus 12 is 37. Alright, so we have done with this possible case. Now we have to check with combination of 3. If you go in combination of 3, right, either you have to go 1, 2, 3. So profit is what? 4, 7, 5. So not fit. If you go with combination of 1, 2, 3, not fit. Combination of 1, 2, 4, 1, 2, 4, not fit, right? Combination of 1, 3, 4, 1, 3, 5 plus 4, 9 plus 3, 12, not fit. 2, 3, 4, 2, 3, 4, not fit. Then we have 1, 2, 3, 4, not fit. So we have explored almost all possible case, number of subsets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All 16 subsets we have tried it, and we found what is maximum profit. Maximum profit is here is 65, right? So we have selected what elements? First and third element. First and third element is giving you the maximum profit, and selected weight is 9 kg. Remember, in this case still 1 kg space is free in the knapsack, but exhaustive search and dynamic programming used to select complete items, or it will not select the item. Remember that we are not going to select the same items again. Only item is selected once. Each and every items are going to select only once. So this is overall profit is going to be 65, right? And we have seen that in previous case that if you are applying dynamic programming, we got answer 65. When we applied exhaustive search, we tried all the subsets of 2 to the power 4. Our answer is optimal solution was 65. If you apply greedy method, right, where fractional weight is allowed, we got 76, right? So now we have to think what is the approximations error. As per this, when you are going to find out, so generally we are going to write 76 divided by 65, right? Right? So 76 divided by 65. If you are going to find out the percentage, then it is going to be 76 minus 65 divided by 65, right? So this is going to be your answer. Nearly 15% error in this approximations algorithms, right? So this is the way, either you write like this, or you can say that, fractional weight directly here, 76 divided by 65 minus 1 into 100, right? Now next is, we are talking about the time complexity, right? Time complexity. What is going to be the time complexity? Since in exhaustive search, just you are applying, we'll go and find the possible solutions for all the given subsets, right? So that basically number of subsets are 2 to the power n. But here, by using these approximations algorithms, we are going to discuss that k into n to the power k plus 1, where number of or value of k are lesser, this complexity will be the lesser values. Number of atoms are lesser, these values will give you the lesser values. So basically it is just combination of linear and exponential n to the power k plus 1. These values are going to give you, like as value of k is equal to 2, then 2 into n to the power 2 plus 1 is 3. So 2 into n cube. So 2 is the constant, so overall complexity will be n cube. So something multiply. If k is n, then what is going to be n into n power n plus 1. So n into n power n. So n to the power n complexity it will come. So depends on the value of k. If k is smaller, lesser complexity will be there. If k is larger, it will go larger complexity. So from where it came, when you are writing that combinatorics problem, NCR, so basically what it is, n factorial divided by r factorial into n minus r factorial. So out of n we are selecting r items. So all out of these four scenarios, right, we are not selecting these all 4 items for the knapsack profitable items. We have selected only 2. Out of 4, you have selected only 2. So if you will go and find out 4C2, right, you will go and find out 4C2, right, what is the values? If you go and find out 4C2, right, we will say that 4 factorial divided by 2 factorial into 4 minus 2, again 2 factorial. So it is nothing but 4 into 3 into 2 divided by 2 into 2. So total is 6. So we are getting there are such cases we'll have to select the 2 items out of 4, we'll have 6 possibilities. And we have seen that exhaustive search method, right, we have 6 possible. One, when we are selecting the 2 items, 1, 2, 3, 4, 5, 6. So there are selection of 2 items, there are 6 possibilities. In that, 1 is going to be your answer. So depends on scenarios, we have to compute these values. Generally that values are going to be lesser than 2 to the power n, right? So exhaustive search time complexity says that it is 2 power n. So here, since you are selecting 2 items, we will be focused on that selection of 2 items, and then complexity will decrease for the given examples. Right, so this is all about knapsack is to find optimal solutions. Knapsack problems can be implemented through exhaustive search, that is the more time consuming algorithm technique. Then you can apply by using dynamic programming technique. It's find in a lesser amount of time as compared to the exhaustive search. Then you have greedy method, right? Then you have branch on bound technique. These all are, technique to find optimal solutions for the given knapsack problem. Thank you.